Hi guys, my name is Peter C. Dr. Junior, mathematics instructor at the University of Liberia and your math tutor. Welcome back to our mathematics tutorial lecture. And in this lecture, we are discussing differential equations. And under differential equations, we'll be looking at determining the order and degrees of differential equations. So this is our example 2. In the previous lesson, we did example 1. So we want to look at some other um, complicated problems or little complicated problems because they are not really complicated. It just of applying some other simplification before determining the degree of the differential equation. So now we have the first problems. The first problem says y prime prime prime. Now I just want to even though it's not really important, but I just want to highlight it. Whenever you have prime, 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 it indicates third derivative. Whenever you have y raised to the third power like this, it indicates the power of y. Whenever you have y prime, 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 it indicates fourth derivative. But traditionally, after the third derivative, from fourth derivative upward, we normally write it like in parentheses. So this is the fourth derivative. This is not equal to y raised to the fourth power. This means y raised to the fourth power. This means the fourth derivative of y. I just thought to explain that just in case we have problems that involve those powers, then we know how to deal with them. So y prime 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 equals 2y prime prime minus y prime plus y, all raised to the power 1 over 4. Now, if we clearly see this problem, we know that the highest derivative is 3. Now, you cannot say you are going to simplify before identifying the highest derivative. No. As soon as you see a problem, the highest derivative in that problem is immediately identified. No matter how the problem appears, you're going to easily identify the highest derivative. What becomes the problem is finding the power of the highest derivative. That's when you will have to look at the entire problem and ensure that the problem is in a much simplified form. So for this, the order is just 3. But let's simplify further, and then we can now get rid of, or we can now determine both the order and the degree of the differential equation. So we said for our problem to be much simplified, we should not have fractional powers. So based upon this, we can get rid of this fractional power by raising both sides of the equation to 4. So I raise this side. This is 1 over 4. If I raise it to 4 as well, so it means this 4 we cancel this 4. So I'll be left with y prime 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 raised to the 4th power equals to 2y prime prime minus y prime plus y. So what is the order of our differential equation? Meaning the highest derivative is just 3. So what is the power of the highest derivative? Is 4. So the degree of this differential equation is just equals to 4. Move to the next one. The next one said du by dx equals to ln of u minus 5. So this du by dx means u prime, because u is the dependent variable, x is the independent variable. So this is u prime equals to the ln of u minus 5. So the highest derivative here is just 1. So the order is now 1. So this u prime raised to the first power, so it means that the degree now will just be 1 as well. So let's look at this one. Y prime prime, or d2y by dx squared plus 5 dy by dx. So this is dy by dx. This is the first derivative, but it is raised now to the third power. Minus 4y plus equals to e raised to the power x. So the highest derivative here, which we call the order of the differential equation, is just equal to 2, and the degree. Now we don't need much simplification because this is much simplified in terms of we don't have a fractional power, and so now what is the degree of this? Now we cannot say the degree is 3. No, even though this power is 3, but we cannot say the degree is 3 because this derivative is not the highest derivative within this differential equation. So there is an invisible 1. This entire derivative is raised to the power 1. So we say the degree is 1. Now look at the last one. Sine inverse of the 3y by the x cubed equals x plus y. Now, with the exception of us getting rid of fractional powers to have problems of such in simplified form, we can also get rid of derivatives within angles of trigonometric functions. So this derivative is within the angle of this trigonometric function. So based upon that, we must get rid of it first. We know that sine inverse of any angle is just equals to that angle. So based upon that, we can say sine inverse of this angle, which is the 3y all over the x cubed. Now, if this was just sine of x or sine of this, we would have taken sine inverse of sine of this function, right? Because this is the same as saying sine inverse of sine of x is also equal to x. So now, this is now equal to x plus y. So sine inverse of an angle is equal to that angle. So we end our problem here. We have the 3y all over the x cubed. So this entire expression now will just be this equals x plus y. So the order of this differential equation, we can all see that the highest derivative is 3, and the degree, which happens to be the power of the highest, derivative, is 1. This whole thing is raised to the power 1, so this is 1. So thanks again for watching. Please don't forget to subscribe to my YouTube channel, please, and also hit the alarm button so that you get alarm to our new uploads. So thanks ever so much. See you in our next video.